Hello students, this is the problem regarding the journal bearing on a centrifugal pump running at 1440 rpm. The diameter of the journal is 100 mm and the load on each bearing he has given as 20 kilonewtons. The factor Zn by P may be taken as 28. Here the bearing characteristic number is given for centrifugal pump bearings. The bearing is running at 75 degrees temperature and atmospheric temperature he has given as 30 degrees centigrade. The energy dissipation coefficient, that is C value, he has given as 87.5 watt per meter square per degree centigrade, and he also asked us to take the diametral clearance as 0.1 mm. So here while you are starting the problem, just write the given data. So the given data is the speed n is equal to 1440 rpm and the diameter of the journal he has given as 100 mm. Load W has given as 20 kilonewtons. Zn by P, the bearing characteristic number he has given as 28. Centrifugal pump bearings, and the bearing is running at 75 degrees and atmospheric temperature at 30 degrees centigrade. The energy dissipation coefficient C value, this is C value, 87.5. The diametral clearance he has given as 0.1. Here the diametral clearance is nothing but the clearance between the journal and bearing. Okay, the clearance is nothing but diametral clearance. So in the problem we will be using a diametral clearance ratio. The diametral clearance ratio is nothing but ratio of diametral clearance by diameter. Okay, diameter of the journal. Okay, these are the given data. So for calculating this journal bearing problem, we must have the help of a data book, that is in page number 19, chapter number 19. We can find the data related to hydrodynamic journal bearings. From 19 to you can find the data. Okay, so you can find the data from 19.3, the Petrov equation, Sommerfeld number, heat generated, heat dissipated, mass of the oil for heat removal rate. So everything can be found out here. Okay, so while calculating the design procedure, remember one thing: while calculating the design procedure of a journal bearing, we need to follow the 5 steps. That is, you need to calculate the length, diameter, bearing pressure, heat generated, heat dissipated. Okay, these are the 5 steps that we need to calculate. If in the question, if he has asked us to find out the mass of the mass of the oil that is required for heat removal rate also, that we can find out. Okay, so these are the 6 steps while designing the journal bearing. You, in the question, if he asked us to find out the design of journal bearing, means you need to find all these 5 steps. Okay, whether he might give the required data or not, we have to find all these 5 steps with assumption data. Okay, so you need, if in the question if he doesn't mention the required data for any of the step also, you need to assume, because we have to design a journal bearing. Okay, the first step is to calculate the length. So the length is already, I think the first step is to calculate the length. So here the diameter is given, that's why we can go for length by diameter ratio, where in the page number 19.14, so see here, in the page number 19.14, you will be finding one tabular column. This is the tabular column where you can find the centrifugal pump, different types of machinery equipment where, okay, so machinery equipment, based on that we can find the data related to that equipment. Okay, so here in the question he has asked us to find out the design the bearing for centrifugal pump. Okay, so for centrifugal pump, that's why we will be taking the L by D ratio. So the L by D ratio we can take it from here, that is between 1.0 to 2.0. You can take any of the data between 1.0 to 2.0. Okay, just I am assuming the L by D ratio as, assume L by D ratio as, I am taking as 1.5. You can take any of the value. Okay, so L is equal to 1.5 D. So the D value here he has given as 100. Okay, so 150 mm. So this is the length value. Okay, so the next we need to calculate the bearing pressure. Okay, so the bearing pressure, here the length is there, diameter also there. The diameter is 100 mm, length, diameter, two things are completed. Next we need to calculate the bearing pressure, that is P value. For calculating the bearing pressure, we need to go for the page number 19.4. The 19.4 in the data book, you can find the formula. Developed bearing pressure is equal to P is equal to L by D. So developed bearing pressure P is equal to W by L by D, where W is nothing but your load that is given in the question, and length we have already found out, and D, okay, the D is already given in the question. So we can find the developed bearing pressure. Okay, so the P is equal to W by L into D. P is equal to, the W value he has given in the question as 20 kilonewtons. Okay, 20 into 10 to the power of 3 by 150 into 100 mm. So I have got an answer of 1.33 Newton per mm square. So this is the value I have got. Okay, so we have assumed the data of length. Okay, so we have to check whether the length that we have taken is right or not. So the value that we got for the bearing pressure, whether it is within the permissible limit or not, we have to check it by using the data book. Okay, so in the data book, you go to the page number 19.14, where you can find allowable bearing pressure. So the allowable bearing pressure for centrifugal pump is between 0.7 to 1.4 Newton per mm square. So the value that we have got is 1.33. So here in the data book he has mentioned as 0.7 to 1.4. So our bearing pressure is within the limits. So we can continue the procedure. Okay. The value of bearing pressure is within permissible limits. Permissible bearing pressure. Okay, so next we need to calculate the steps, that is length calculated, diameter calculated, pressure calculated. Next we need to calculate the heat generated, that is QG. Okay, for calculating the QG, we have to go for the we have to take the formula as QG is equal to mu into W into V. Okay, so this is the formula that we need to calculate. So this formula can be found out from the page number. Heat generated during the operation is equal to Hg is equal to, or Qg is equal to mu into W into V. So where mu is nothing but coefficient of friction. So the coefficient of friction can be found out using the formula from Mackey's equation. From Mackey's equation, mu is equal to 33.25 by 10 to the power of 8 into Zn by P into D by C plus K. So these are the values that he has mentioned in the formula. So first we need to calculate the coefficient of friction. Okay, mu is equal to 33.25 by 10 to the power of 8 into Zn by P into D by C plus K. So this is the value that this is the formula that we are having. So here Zn by P is already given in the data book, or in the question itself he has mentioned Zn by P may be taken as 28. Okay, 33.25 by 10 to the power of 8 into 28 into D by C. So the D by C is nothing but, so here in the question he has mentioned as diametral clearance, that is nothing but C minus D. So C minus D is equal to 0.1 he has mentioned. So the diametral clearance ratio is nothing but C minus D by D. Okay, so the 0.1 by 100, that is equal to 0.001. Okay, so 0.001. Sorry, this is capital D minus small d, and this will be capital D minus small d. So the difference between bearing diameter minus journal diameter. 1 minute. Diametral clearance is nothing but the difference between dia of bearing and the journal. C is equal to D. C is equal to D minus D, that is 0.1 he has given. Now the diametral clearance ratio is nothing but ratio of diametral clearance to the dia of journal. Okay, dia of journal. Okay, D minus D by D. So we got 0.001. Okay, so in the question he has mentioned as 0.001. So in the formula we have D by C. So D by C is nothing but, so in the formula D by C is mentioned. So here this will be the C value and this will be the D value. Okay, C by D is equal to 0.001 he has mentioned. Okay, so but in the formula he has mentioned as D by C, so that's why I am taking as 0.001. Okay, so this is the value. Okay, plus K. So here the K is nothing but your end leakage factor. So the end leakage factor can be found out through this graph. Okay, so here the L by D ratio, if you go for L by D ratio, that is length will be 150 by 100. 150 by 100 will be getting around 1.5. So the value will be here. So just go straight to this. If the value that touches this curved line, we have to take that value. So here it is touching. Okay, so just go to the left. So here is that value. So maximum the K value will be lies between 0.02 to 0.025. So here obviously 0.05 means this value might be 0.025. Okay, so here it is touching here, that is around 0.02. Okay, so I am taking the value as 33.25 by 10 to the power of 8 into 28 by 1 by 0.01 plus 0.002. Okay, this is the value that we need to take. Okay, so after calculation of mu, we will be getting an answer of 0.011. So this is the value that I have got. Just check the value whether it is correct or not. If not, just let me know. Okay, so after that we need to substitute the value. So mu we have calculated, W is nothing but your load, V is nothing but your rubbing velocity, that is nothing but pi dN by 60. So this is the formula we are having, that is in the data book. Let me show you. So I think it is not there in that data book. Just remember the value of V. The V is nothing but rubbing velocity, or the velocity between the adjacent layers of oil. Okay, the lubricating oil. Okay, just substitute the values. So the pi into diameter he has given as 100 into the speed he has given as 1440 rpm. 1440 by 60. Okay, these are the values that we are having in the question, or that we need to solve. Okay, so the Qg is equal to, for conversion of units into watts, just substitute the values as 0.011 into 20 into pi into 0.1 into 1440 by 60. So we can get the value of around 1658.61 watts. The heat generated will be in watts. So next we need to find out the heat dissipation. For calculating the heat dissipation, we have a formula of, in the page number 19.5, we have a formula Ca into Tb minus T minus Ta. C is nothing but heat dissipation coefficient, which will be, 1 minute. So heat dissipation coefficient. So if in the question, if we mentioned as unventilated bearing or ventilated bearing, just take the values from the data book. If he has mentioned the C value, that's fine, just use that value here and you can substitute the value and you can solve the formula here. But if he doesn't mention the value, means just assume that as unventilated bearing or ventilated bearing. If he has mentioned any of the thing, just use the values from either of the one. If he doesn't mention, means just assume the value as unventilated or ventilated. That will be lies between 490 to 1400 or 140 to 420. Okay, these are the values and you can use any of the values. If he doesn't mention the value of C, or if he doesn't mention which type of bearing it is. Okay, so use, in the question itself he has mentioned as the C value. In the question he has mentioned the C value as 87.5. Okay, so heat dissipated is equal to CA TB minus TA. So what is the TB here? The bearing temperature. The bearing temperature he has given as 75 degrees and the atmospheric temperature as 30 degrees. Okay, the 87.5 into the area will be, so the area will be the projected area. Okay, the projected area is nothing but 0 length into diameter. Okay, 75 minus 30, that's what he has mentioned, right? 75, the length is nothing but 87.5 into 0.15 into 0.1, 75 minus 30. Okay, so calculate the value and tell me the answer. Okay, next we need to calculate the amount of artificial cooling required. So the amount of artificial cooling is nothing but, if the cooling is not removed through air, means if the heat dissipated, what heat generated is greater than heat dissipated, means then we need to use an artificial cooling. That means we need to arrange some pump for removing of a heat from the bearing. Okay, so the amount of artificial cooling is required only when the heat generated is greater than heat dissipated. Amount of artificial cooling required, Qg minus Qd, that is equal to, the Qd value I have got around 59.063 watts. Just check the value and tell me the answer. If any one of you got a different answer, means we will check that. Okay, so here the heat generated is 1658 and here the heat dissipation is 59.063. obviously we need an artificial cooling. Okay, that is the end of your first problem related to bearings.